Okay, so JLL, you fairly recently published a new report, The Future of Quantum Real Estate. I guess it'd just be good to understand the background to that. Was there a particular sort of thing that triggered it, or you just thought it was time to do it? Just, yeah, and anything you can share as to why now, I suppose.
Yeah, that's an interesting question. It's one I've been asked a lot now, and I think particularly as well as 'cause quantum is not new, quantum computing. I remember being asked about this in conferences up to probably about 10 years ago in related to data centers, and it always felt like something that was quite far away or quite distant. But 2025 has been highlighted as the year of quantum computing. And we've seen a number of significant breakthroughs throughout the year, particularly when it comes to the quantum chip. So the four big tech companies have all made major technological breakthroughs, and it now feels that we're really sitting on the precipice of where we're starting to see quantum computing coming through, and the commercial viability is on the horizon or just around the corner.
Yeah, I mean, I guess it's interesting, particularly bearing in mind, everyone's sort of obsessed with AI for obvious reasons. So that's kind of focusing most people's attention now. But you think quantum is a sort of about to make I don't know whether it's a similarly big splash or at least a significant impact in the market so soon, and when everyone's still, not fully understanding what they're going to do with AI. Just how do those two sort of play out,
Yeah,
if you like, at the moment?
Yeah, that's an interesting one because we took the first writing this report. The first kind of approach we took is to compare or to have a look at what we saw leading up through to the breakthrough of AI, and what we found looking at the investment volumes is that quantum computing is lagging behind by about 10 years. So it's going through the similar pattern that we saw building up to AI, but probably around 10 years further down the line. So what we're seeing, like for early quantum, like between 2016 and 2019, we saw this was the kind of the early phase that we saw probably around the early 2006 or so for AI, where investment was pretty much mostly venture capital, and we saw investment volumes around 300 to 500 million a year. But then we started to see from 2019 or 2020, and the next last 4 years or so, it kind of jumped. We saw investment volumes between 2 and 3 billion, where we start to see that kind of early acceleration phase that we again saw with AI, where it suddenly we saw this big jump up where we start to see the excitement coming through, and then we start to see that mix of not just venture capital, but a blend of venture capital and M&A activity, where we start to see those companies make bigger bets because it's coming up to it. And then 2025, we saw the investment volumes at the halfway point in 2025 reached about 3 billion. So we're on course to see, if we see the same level of volume throughout the year, we're on course to see 6 billion. So we see that leap up. And I think what we saw with AI is that we start to see it gradually increase until we had that breakthrough, that chat GPT moment of 2022, when suddenly investment volumes leaped even further still, because that was the first program. We had kind of like introduction to AI, but it was all through playing a grandmaster at chess or being used in Go. But ChatGPT was that first commercial application where everyone was like, okay, we really see what the use case is for it. And we predict that we're going to see that ChatGPT moment in probably within the next 5 or 10 years or so with quantum computing.
Okay, and you say obviously that we're near commercial viability, and to that point, I think you've identified there are a number of quantum ecosystems or hubs across the world, and they all seem to share a sort of common set of ingredients in terms of what's making them successful. So yeah, tell us a bit more about what's involved there.
Yeah, we were looking at what the ecosystem looks like at the moment, because we've got a number of quantum hubs around the world that have now started to develop. And we thought it would be interesting to see what those key ingredients that make a quantum hub, because it's actually different from what we see with the data center or AI phase, where they're primarily centered around academic or key research areas within the country. So it will be they're largely partnered with a big university, one with strong research and academic profiles. And we start to see there's the US has made significant amount of investment within there. So we see a number of key quantum ecosystems developing within the US, but the same with China and the same with the UK and in Europe as well. So in the UK, the example is that it's largely centered around Oxford in the campus in Harwell. But we start to see the ecosystem is developing within that golden triangle of Cambridge, Oxford, and London, where you've got the kind of the talent and workforce that's available. The 6 areas that we highlight in our report, the key ingredients, and some of these are more important than others. They're not equal, but it's having that private sector that's available there. So in order to kind of support that growth and access to private funding, you've got the academic institutions that I've highlighted and the workforce that's available. We always forget, even with data centers, the workforce is a really key ingredient. Actually, we highlight that the infrastructure and the workforce are going to be the 2 most important for these. Staffing, even with data centers, is incredibly important and really hard to get that very specialized workforce or the talent that's needed. And then the others is which is key, is government support, that public-private advocacy, and then the physical infrastructure that's available there.
Okay, and sort of talk of infrastructure, I guess, moves us on, because I think you're suggesting that where we are now, shortly there will be a build out, or the starting of build out of quantum computing real estate. So the data center opportunities are going to be there. I don't know, is there a particular time frame you anticipate, or is that a little uncertain? Or so what is the opportunity, I guess, data center wise?
Yeah, the time frame is a difficult one. I think it does largely depend on what the technology breakthroughs that we see, and there are some blockers to kind of how we see that develop out. So it's kind of overcoming those key issues. At the moment, the quantum ecosystem is largely around controlled environments. So they're typically purpose-built lab environments, kind of separate or kind of connected to an academic institution, and that's what we're seeing at the moment. They're built out at the moment, and we will see the error rates for quantum bits will start to come down, the coherence will improve. But as we start to see that evolve, and this is where we are at the moment, we're going to start seeing examples of these co-located pilots. So where we start to see quantum and data centers built in a hybrid environment, where we start to see them integrated but on limited trial instances. We've already got an example of this in Germany, where they're trialing in Zurich, where they're trialing a kind of a controlled hybrid environment with a data center and quantum computing. And we'll start to see that evolve over the next 5 years. It's a difficult one because quantum is incredibly fragile, and to have it next to or within a data center in a hybrid environment where data centers are incredibly noisy, it's difficult to kind of have that environment. You need a lot of infrastructure available within that to separate the two, but have them connected. And then in the third instance, where we start to see probably within the next decade or so, is that commercial hybrid approach, when we start to see quantum utility achieved, and we start to see those benefits, and we start to see the commercial viability of quantum, and then we start to see new data center developments. Quantum will be a common feature in some of those, particularly within big hyperscale facilities.
Yeah, and in terms of that hybrid, I'm interested perhaps if you can compare or contrast with AI, because largely it seems that people are building dedicated AI, new data centers. Clearly there is some AI within existing ones, so there's a bit of a mix of what you call classical and AI. But you think quantum will be more likely to be incorporated within existing data centers in a hybrid model, as opposed to building out big new quantum only data centers, or how do you see that landscape evolving?
Yeah, the potential for AI is huge, because it's similar with how we're trying to get trying to pull across the point that AI doesn't replace the need for traditional data centers. You still need those traditional data centers there, because we always often get asked the question, does that mean that traditional data centers are dead? We're not going to see those, but we still see AI is for a very specific use case. And this is the same with quantum. There's a very specialized use case that will require quantum computing. So we see them as very complementary, as we do with traditional computing and AI. We see AI and quantum as a very complementary environment. They AI can help make quantum systems more reliable. They could be used to help reduce the error rates, and they help fine-tune performance. But at the same time, quantum computing can really supercharge AI. It offers new ways to train models. It can optimize algorithms, and it starts to be able to help tackle those biggest problems that are currently out of the reach of today's computers.
Okay, and in terms of quantum computing infrastructure specifically, is it particularly challenging to build that out? I mean, are you able to describe what a typical hybrid quantum facility might look like, I guess?
Yeah, they require at the moment really highly specialized environments due to that fragile state that the qubits are held within. So the cooling systems are completely different from what we see with data centers. They're held in a cryogenic cooling. So they're kept at minus 270 or so degrees. And they have complex control systems in order to protect those qubits from any noise or decoherence. So it adds to that challenge of combining quantum and classical computers together. But we're starting to see, as I mentioned earlier, we're starting to see those kind of trial hybrid facilities where we start to see them being located within the same one, but with a controlled environment separating the two. I think at the moment, it's incredibly important to have them held within the same city, with the same facility. The latency is really important if they're working together, but it's overcoming those kind of key issues initially, particularly with the kind of the cooling and the keeping them in a fragile state.
And in terms of, I mean, obviously the data center industry is under quite a lot of scrutiny in terms of power consumption and cooling is part of that. I mean, is cryogenic need a whole new level of power, or is it very energy efficient, or you know, where does it sit within that you know, being a big consumer of power or not? How sustainable is it, I suppose, is the question.
Yeah, it's a really difficult one to make a direct comparison with. Even though quantum computing requires a lot less power to do a really high level compute analysis, but the level of that is incredibly, is so much more higher than what AI can achieve. So you can't make a direct comparison there. But as you mentioned, the cooling environment requires a significant amount of power. But what we'll see is that quantum won't be used for everything. It will be used for those very specialized industry use cases. I think what we were keen to get across in the report is, because classical computing uses the binary ones or zeros, but the world doesn't really work in ones or zeros. It's very messy. When quantum computing can do simultaneous equations a lot quicker than what we can see with classical computing. So that's why we start to see the industry use cases for quantum computing can solve some of the world's biggest problems, and we'll start to see the industry use cases, or the industries that will be impacted from quantum computing will be huge and significant. I think the key one that we hear a lot about, we highlight 9 industries that will be impacted massively from quantum computing, but cryptography is a huge one that we're seeing governments invest a lot of money in a post-quantum cryptography world. So quantum computing can crack any of the what we use for most of the encryption code, which is solving a very large equation to very large prime numbers together, which would take classical computers more years than we have left in the world to solve, but quantum can do that in a matter of minutes. So we start to see the abilities for you know the possibilities for it will be huge, and the ramifications will be massive as well.
And in terms of the way most organizations will access quantum computing, is it like AI in the sense that the hyperscalers will build out the majority of the infrastructure and people will access it as a service? Is it quantum as a service the likely way for most people to consume, because the cost involved in building out their own quantum computing infrastructure is just too prohibitive? Is that how it works?
Yeah, that's what we highlighted in our report. So we see that quantum as a service is the likeliest route, or the likeliest model for commercial adoption. Building quantum computing is prohibitively expensive at the moment. So we'll see that quantum as a service will be the way for most organizations to access quantum technologies, and that will be via the cloud. It actually is already offered as a service. AWS Bracket is currently a quantum service that you can access. They do it via what we see at the moment. They do it through partnerships with quantum companies. But what we'll see and how that will evolve is that we'll start to see those big hyperscalers will start integrating quantum computing within their own facilities over the next 5 or 10 years. It probably even sooner, if we start to see the commercial viability for it push forward. But we'll start to see those examples of on-premise ownership. And we'll start to see, as we do with GPUs as a service, we'll see quantum as a service as a really premium option, including kind of subscription plans around that to access those resources.
Okay, so maybe in terms of summarizing, clearly AI is having a seismic impact on the data center market now and the wider IT world. Is quantum computing sort of similarly, is that going to have a similar impact over the next few years, or will it, because AI is just such a huge thing, will it seem smaller by comparison? Just I suppose, I guess it's the compare and contrast those two things.
I think, yeah, it's always a difficult one because again, with AI, we start to see, and we still haven't got to the full level of what the commercial viability of AI is. I think most of our route to what we see with AI, or most of us using it at the moment, is via a chatbot or for kind of a chat system. But we still haven't seen it fully. We're starting to see it now, but we haven't seen it fully integrated in everything that we do. But we start to see that slow increase with that. With quantum, it's a very specific, so there's industries that will be impacted a lot greater than what we see with AI, but they're very specific ones. I think I highlighted earlier with the ability to kind of the very for modeling is huge. It's going to be a massive game changer for that. One, and we see it highlighted a lot. One of the industries that we highlighted within our 9 industries, and one that a lot of people talk about with the biggest impact, is drug discovery. We still, and I think a good example is with the caffeine molecule. We understand what caffeine does to us. It gives us a buzz, it keeps us awake, and everything else. But we still don't fully understand what the caffeine molecule does to individuals, like how it impacts, because we have millions of electrons within us, millions and trillions of cells within a human body. We don't really fully understand why people are impacted significantly different from that caffeine molecule, why some people are much more sensitive, or other people have different impacts to others. And the same with drug discovery. We have the ability to then see why new drugs, when they're fully launched, like how it will impact individuals, how it impacts diseases, and it will really cut down the time it takes to kind of release new drugs or new vaccines into the world. And it will have massive ramifications in terms of, the life sciences sector within that. Another one, and we didn't highlight it hugely in the report, but it's one that we've been thinking about now in the world, is that is timekeeping. We rely on 30 satellites for the vast majority of all timekeeping. Every transaction that goes through is used and global positioning systems relies on these 30 satellites, and some of those date back to the 1990s. And a solar flare or anything that happens to them has the potential to wipe trillions and trillions off in terms of the world. But with quantum, we can use it for very precise timekeeping, or it can be used as a backup to what we use for our GPS for these satellites that are in the world. So yes, there's some really interesting use cases from what we see from that, but they are around very specific industries.
Yeah, and I'm guessing that there's no, in the way that AI at the moment is sort of the big number crunching, and then we're going to have inferencing and AI at the edge, etc. There isn't a quantum computing at the edge equivalent. Is that right? And it'll always be huge centralized computing. Is that, as far as you understand it, that's the likely roadmap?
Yeah, that's what we see at the moment. Again, we will start to see that integrated in any new data center developments. There will probably be, particularly from a hyperscaler point of view, we'll start to see quantum being installed within those. But at the moment, those ecosystems are in very specific, particularly centered around those kind of major research hubs. So yeah, Chicago is a good example in the US, and in Oxford in the UK. We'll start to see that integrated into cloud. I think again is what we see as the kind of the likeliest route to what we see quantum computing evolve out. So it'll be offered within a cloud system, but again, like I highlighted earlier, it's prohibitively expensive to kind of build out these quantum facilities. So we won't see them kind of evolve like we see with the edge being really close to the end user. It's not quite as important for that.
And just finally, I mean, everyone's wrestling with AI, then quantum is just around the corner. Is there anything else to worry us beyond quantum, or can people relax in inverted commas that they've only got these two things to wrestle with for now?
I think it's yeah, it's always we've seen it as kind of a natural evolution of where we're seeing, because we're still seeing those GPU chips get smaller and smaller. So miniaturization is still happening. We've gone from 5 nanometer to 3 nanometer to now 2 nanometer, and we're seeing the latest GPU chips, the Blackwell Ultra, the ability of those, the enormous amount of computational power that these have is enormous. But we'll start to reach the natural progression of Moore's law is that we'll start to see there'll be a point, there'll be a wall to hit where we start to see that evolution from the silicon age to the quantum age. And that's where we'll start to see where the kind of the GPU chips will kind of start to be used for that. But we don't see it as a replacement. We see it as kind of a complementary ecosystem. In terms of the kind of the next stage from that, I would hate to hazard a guess. I think even if you told me 10 years ago when I started in the data center industry or started tracking it, it's the power of what these GPU chips would be. I wouldn't believe you. I wouldn't be able to even hazard a guess at that. But yeah, I think quantum computing is probably enough to kind of get my head around in this early phase.
No, it's brilliant. I mean, thanks so much for giving me your time and sharing the insights onto quantum computing. It's fascinating to watch it. So yeah, really appreciate it. Thanks again, Daniel. Thank you.
Brilliant. Thank you very much.